All right, so now we're recording. So again, this is the first lecture. This is just an introduction. We're just gonna go through what we're gonna do, why we're gonna do it, um, and we're gonna the point of these lectures are to give you guys a tool set. Um, in classes, you may not be taking these sort of classes, or your major might not be lined up, and so these are the goal of this is to try to add a tool set under your belt. And even if you're not going to go into data science, we'll explain why it's important to have these tool sets. And basically, yeah, the point of this is to add skills using projects. We're going to go through a single data set, a single project throughout the semester as we learn different techniques. And so it's important, what exactly is data science? And it's a field that uses scientific methods, processes, algorithms to extract knowledge and insights from structured, unstructured data. We're not really going to be talking about unstructured data, but to give you a sense of what structured data is, it's what's extracted from websites. Every time you log into Google, they're extracting a lot of data, or different surveys, different forms. This is the age of big data. A lot of data exists out there. It's very easy to extract data. And so we need to use data science to extract insights, to extract knowledge, and to understand what's the story behind this data. So why should we care? Why should we learn data science? Why should we even bother with this? So according to Glassdoor, for 4 years in a row, data science was the #1 job in the US. And the US Bureau of Labor Statistics, data science, the demand for it is going to increase up to 27% until 2026. And so this is a pretty big increase, right? Because the demand is pretty high and it's still increasing, but the supply of good data scientists is staying the same or not increasing at that pace. And so this gives you guys a lot of opportunities for high paying jobs. And so the main goal of data science, it's to build predictive or descriptive models of real world phenomenon given real world data. Let's break this down a little bit. So let's start off with this models. You guys are kind of indirectly familiar with models, what models are. Let's say we have some graph, right? XY graph. And then we have, let's say, some point right here, some point right here, all the way through. You guys can pretty easily tell that the function that this data maps to is just a linear, right? Like f of x is equal to x, right? This is just a regular linear function, or it's a line, right? And so this is the goal of data. This is a model. We had some data over here, and we want to map, or we want to learn some insight. We want to learn some descriptive properties of what this data is. And so we can come up with different models, and usually these models are functions, or they might be visualizations. And we'll talk about that later on, but this is the goal of data science, to build these models. And these models take the forms of predictive or descriptive. Okay, what do I mean by that? When we have some, let's look at this linear function. It's just a line, right? What if I gave you the input of right here, of let's say this is 5. You guys can easily tell, right? If we just put it into this function, the output should be 5, right? And so this is a predictive model. We didn't have an input of 5 inside our data. But using this function, we learned that, okay, if we're given some 5, then the output should be a 5. And so this is what data science tries to do. Using data, it tries to come up with different functions, using different algorithms that we'll talk about, using different techniques. It tries to come up with these predictive or descriptive models. Descriptive are a little bit different. Descriptive kind of falls into the realm of data analysis, But this takes the form of data visualization, bar charts, line charts, which we'll talk about also. But this is the power of data science, where given data, and we have a lot of data, right? Generated from websites, generated from companies, from research institutes. We want to come up with insights into what this data looks like and how we can improve businesses, improve, give recommendations to people, because just this data is meaningless. But using the algorithms and different techniques, we can improve we can use data-driven techniques to improve businesses, to improve individuals, and to provide recommendations. And almost every industry uses some form of data science. It might not be called data science, but every industry needs some form of data analysis, data processing, whether it's biology, physics, business, marketing, they all need some form of this. If you guys have any questions, feel free to interrupt. Yeah. All right, so data science, the ideas are not new, or the field is kind of new, right? Data science uses data, but with computers. It's heavily computer reliant, because data today has gigabytes, sometimes petabytes of information. We're not going to be working with that kind of information, but with big companies like Google, Facebook, they have lots of data. And so processing this, you can't just do it by hand. And so it requires a lot of computing, a lot of computer programming. But that's where data science comes in. But the ideas, the philosophy of data science goes back hundreds of years. And just to give an example, Johannes Kepler, he was an astronomer and mathematician. And if you're not familiar, basically he came up with Kepler's laws. And basically these are the orbits of, he came up with the orbits of planets follow an elliptical orbit. And the way he did this was he used data from Tycho Brahe, who was a businessman and astronomer. And Brahe had very accurate locations of where Mars was throughout the sky at a particular day. And he had years of this data. And so this is sort of an example, this graph shows an example of what that kind of looks like. And using this data, Kepler was able to come up with a model, right? You guys can see with this image right here, the model, it forms this sort of pattern. And using that pattern, Kepler was able to come up with his laws of orbits, of planetary orbits. And so this is a really good example of data science. Obviously, back then, they didn't have computers, they didn't have processing powers. But this is data science. It's using mathematical techniques, statistical techniques to come up, to find insights in the data and to come up with what the data looks like and to extract insights and knowledge from this data. Now, this is kind of an example of a descriptive and predictive model, right? Using the model Kepler came up with, you can predict the orbits pretty well. But it also describes the physical process. It describes the physics of the real world, right? And so this is both a descriptive and predictive model. This is just one example of that. So the structure of the lectures, I'm going to start off with, this might change, but I'm going to start off with the general explanation of the concept, technique, or algorithm. And then we're going to apply that to the data set. I'll talk about what data set we're going to be using, but we'll be using code, we'll be using different I'll talk about the programming languages, but we'll be using the code to apply it to the data set. So it's both real world, so you can understand what the algorithms and techniques are doing, but also applying it to a data set. And so this might change, but basically we'll go through some data cleaning, visualization, Linear regression, you guys might be familiar with that, but logistic regression, decision trees, naive Bayes, random forests, neural networks. Um, these are algorithms, most of them. Some of them are techniques that can help us extract insights, help us extract knowledge from data sets. And so this is the main portion of what we'll do today, just to get started, just to get the tools ready for what we're gonna do. And so there's two options I'm gonna give you guys. You guys can use Python and R. These are sort of the industry standard tools, the programming languages that are used. And I'm gonna try, my main expertise is in Python, but I'm gonna try, you should be able to walk through both of these in whichever language you choose. So whichever one you're comfortable with. If you're not comfortable with either of them, that's fine. I'll try to break them down for both programming languages. But just know that these two are available for you, and it depends which one you want to use. R is more used in data science, data analysis. Python is more general purpose. You can do more things with it, but R is more focused for data science. Okay, so so if you want to go with the R path, you have two choices, either RStudio or RGUI. Both of them are fine. They both work really well. RGUI, so click on that link and then go to the download R section. And then you'll come up to this page right here. And then these are just places to download. Basically just go all the way down to the USA portion and click the first one. The first one is fine. And then you'll be taken to this page. You'll have three options depending on if you're on Linux, if you're on Mac, or if you're on Windows. And so just click, I'm on Windows, so I'll just click that, and you'll be taken to this page. And then you want to click the base, which is this is going to install the base version of R. And then once you click on that, you'll be able to download the executable. And then it'll take you through the steps to download that. That's if you want to use RGUI. If you want to use RStudio, so click on that link and then go to this page and then scroll down a little bit and then you'll see the RStudio desktop. And then if you just click download, and then it'll automatically detect which operating system you're on, and then just click that executable and just follow the steps and it'll download that for you. All right, if you want to go the Python path, you have three options for this. You can download the raw version of Python and just go to the website, click on downloads, and then just click on this button. This is going to install the latest version of Python. This disclaimer, this is you will have to download packages, libraries. They are sort of easy to do, but sometimes there's errors that come up. And so this is not my most recommended. If you want to do it, by all means do it, but basically you'll have to download individual packages because specifically for Python, also for R, there's different packages, there's different libraries that make data science very easy to implement, the algorithms very easy to do. And those aren't pre-installed. And so you'll have to, I'll talk about installing those if you guys want, but when we get there, but just know that you will have to install that. Next choice is Anaconda. This is what I use. This is kind of built for data science for Python. It comes pre-installed with all the packages, all the libraries that you'll need for data science. And again, depending on which operating system you're on, just download the graphical interface is fine, whichever operating system you're on. A disclaimer, it is very heavy. It's about 34 gigabytes. So if you don't have the space, don't do this. The reason for this is because it comes pre-installed with all the data science packages. And so you don't really have to worry about downloading anything. Like once it's downloaded, you don't really have to worry about it. And so the final choice that you have with Python is Colab. And this is a pretty good choice. It doesn't require any downloads. It's provided by Google, and so basically all you do is you go to some. It's all web based, so none of it runs on your computer. It all runs on Google's end, and you can run Python code on this. And it comes mostly pre-installed with the libraries, the packages that are needed, but it's very easy to install if it's not installed already. This is probably the easiest way. Um, some things like graphical visualizations are a little more difficult with this step, but just to let you know, you guys have this choice if you don't want to download anything, let's say. And so, yeah, I'm going to try to walk through both Python and R during the lectures when we're actually implementing these algorithms and applying it to the data set. And so you should be able to follow along with both, whichever one you're doing. If you run into problems in solving it, let me know. I can try to help that. So finally, I've been talking about data sets. I've been talking about data. When are we going to see data? And so this is the data set that we're going to work with. So let me introduce Kaggle. It's a data science platform and community. They have a lot of data sets. They have a lot of examples, and they have competitions. Many of them are paid, so you can actually make money off of this. And so, yeah, basically, it has a lot of competitions, a lot of data. And this is a data science community. You guys can look at it. I encourage you to mess around with it, look at the different data sets, different examples that people have. But the specific data set that we're going to be working with is the Titanic data set. And the reason we're going to do this, it's easy to get started. It's easy to understand. And so this is a data set of Titanic, of what happened that day, basically. There's a question, do we need to have experience in Python to properly go through the lectures? I'm going to try to break it down as simple as possible so you probably don't need it. Obviously, it doesn't hurt, but I'm going to try to break it down as simple as possible. And most of the libraries that we can download, they make implementing these very easy, like making visualization easy to do in just a few lines. And so it's not too hard if you don't have experience, it's not too hard to understand and follow what's going on. So yeah. Yeah, so this is the Titanic data set. The goal or the competition per se is to use algorithms to create a model that predicts who survived the Titanic shipwreck. And so basically this is the data set of about 1,500 people died of the 2,000 people. And we have different descriptions of who these people were. And so we want to predict if these people survived or not based on data that we're given. Will the libraries from Anaconda be the same on Spider? I'm not too familiar with Spider, but I believe Spider is just a web-based, I believe so, because Spider is just web-based, right? It's just Anaconda, but on the web, I believe. So if you install Anaconda, you should have all the packages essentially. I'm not sure if you installed Spider separately. I'm not too familiar with that, but yeah. But if you install Anaconda, and Spider should be there too. Perfect. Okay, so this is like the first step of what you want to do when you're looking at Kaggle, when you're looking at competitions or doing your own projects. You first want to read the overview, what's it about, the description of it. But then you want to go to the data tab. Oh, by the way, I forgot. You have to make an account for this. It's free. I believe you can just use a Google account or GitHub account. And then you have to click join competition. Since I already joined it, it doesn't have it for me, but in the right side, it should just say join competition, and you should be able to. So yeah, go to the data tab, and then it'll have a description of the data that were provided. And so we can see the data has been split into two groups, training and testing. This is a common feature. This is what you're going to see very, very commonly. You split it up into training and testing. Training is what you do to build your algorithm, to make your algorithm learn, to build your model. The testing is to see if your model is actually good, right? This is sort of like you learn something in class. You learn how to do 1 + 1, and then you go to take a test. If you actually learn how to do addition, you should pass that test. You should do well on that test. If you just memorized 1 + 1 = 2, you're going to do bad on the test. Algorithms, different that we'll talk about, they have these same problems. They can sometimes memorize data, or they can sometimes not generalize. They can sometimes not learn. I'll give you a quick example. We'll go into this a little bit more, but let's say we have some data and it's taking the shape of like this. And then let's say our algorithm just memorizes, okay, it's going to be exactly like this. Our function, our model is going to be exactly like this. Well, let's say we give it a new input that it's never seen before, like right here. And it just doesn't predict it. Let's say it doesn't understand, it just goes off and predicts something incorrectly. That means it didn't learn. It just memorized the data. It just memorized how to do 1 + 1, but it didn't understand. It didn't generalize to other concepts. And so this is common. We have usually one training data set and one testing data set. All right, so let's look at what exactly is provided in this data set. We have survival, and this is 0 = no, 1 = yes. This is what we want to predict. Did the passengers survive or not? And we'll give it a 0 if they did not survive and a 1 if they did survive. We have the P class or a ticket class, and this is the first, second, third, the class that we're in. I believe this is dependent on the money that you had at the time. The sex, the age, the number of siblings, number of parents, ticket number, passenger fare, cabin number, and the port that they embarked on. We can kind of come up with some hypotheses already, right? We can kind of come up with like ticket number, is that really going to matter too much? Maybe not. The age and the sex, would that matter? Probably, right? Women, we kind of know that women and children were probably the first to go, first to be saved, and first to have the ability to go on the boats. And so this is what the data science process is. We get our data set and we look at the features. Sometimes the features aren't given. Sometimes we have to come up with the features. But in this case, we're given the features, and we have to, given the context, we have to come up with which features are relevant, which do we care about, what is going to affect the survivability. And so we can start with some hypothesis and test it. And then maybe, I don't know, maybe ticket number does affect whether you survived or not. We'll see if it does, using different algorithms, different techniques. But yeah, see, and this is a description of the different features. By features, variables, these are all replaceable. I mean the actual features. So for example, age is a feature. It's a variable. I'm going to use that interchangeably, but it's something that, it's some data that's provided. And so, yeah, the class, it's dependent on the socioeconomic status. So first is upper class, second is middle class, third is lower class. I think we can kind of come up with some hypotheses as to, okay, the lower class probably didn't have as much chance. And so we might be able to come up using the data. Well, obviously this is our hypothesis, and we'll be able to test that using different techniques. So yeah, so what you want to do is, we can see our data, and Kaggle does a good job of describing what the data looks like. And we can see we have some, let's look at the train CSV. And we can see all the features that it has, right? It has passenger ID. And so this is going to be the first passenger. And then it has the if they survived or not. Remember, 0 is they didn't survive. 1 is they did survive. And then the P class, this is their socioeconomic class, and so on. All their names, different things, different features that they have. And so what we're going to first do is use this train.csv, this training data set, to build our algorithms, to explore, to visualize it, and to try to predict, to try to build these models as to what's going on. And so the first thing you want to do is download these. Go click on, make sure you've clicked on the train.csv, and then click this download button. I've already downloaded it, so I'm not going to do it, but save that into somewhere you'll remember. And then let's look at the test.csv. We have the same thing. It looks very similar. Passenger ID, the P class, the name, the sex, the age, so on. But you will notice something. The survived doesn't exist, right? We had survived right here in the train.csv. Survived doesn't exist in this. You can go through the entire data set. It's not going to exist. The reason for that is because we have to come up with the survived. Using this data, the P class, the name, etc., we have to predict if they survived or not. And then once we determine if they survived, we put that into a separate file, and then we submit that to Kaggle, and they'll be able to grade us. Survive is what we're testing. That's exactly right. It's what we want to predict. It's what we want to find. Using the different features, age, sex, socioeconomic class, we want to predict whether they survived or not. And so this is an example submission. Basically, what Kaggle is doing is showing us that these predictions assume only female passengers survive. That's one model they've built. Maybe they think that only the females survive. And so what they did is basically for all the females, they put them as survived. And for all the males, they put them as not survived. And they submitted this. Obviously, it's not going to get as good result. The score, the accuracy isn't going to be as high. But this is just an example of we're gonna train using the train.csv. We're gonna come up with visualizations. We're gonna come up with different algorithms using this train.csv to make it learn. Right? We're gonna have our computer go to school. We're gonna teach it that this matters, and if this happens, then they survived. And we want it to learn that. And then we want to train it, or we want to test it. We want to see, did it actually learn, and how accurate is our model? And so we'll use the test.csv to have our computer, have our algorithm predict if they survived or not. And then for all of these, for every single test.csv, every single test data set, we're gonna put that into a submission file and submit that to Kaggle. And they're gonna score it, they're gonna grade it, and they're gonna see that how well do we do. And so and then we have some common leaderboards, right? It's a competition, and so there's different scores. So one score obviously means for this particular competition, it means you got everything right. Every single prediction was correct, and so you get a score of 1. And so that's our goal. We're gonna learn the algorithms, we're gonna learn the techniques, and then we're gonna apply it to this data set. We're gonna try to come up with insights, try to come up with knowledge of what the data is telling us, and then we're gonna submit this as a submission to this Titanic competition. And this is what really is, it's kind of reflective of the real world. Your company, a business, a research institute will either give you some data, or you'll have to collect the data, and then you'll come up with the insights, you'll come up with the knowledge and submit this either to your manager, to a peer-reviewed paper, or so on. That's it for me. I'll stick around if you guys have any questions, but um, this is the goal. We're to to give you guys the tool sets, to give you guys the tools to be able to understand insights given a data set. And let me stop recording.